Hi, welcome to this first inquiry activity for this chemistry course. And in this inquiry activity, we are going to be looking at the fundamentals of experimental design. Anytime you take a chemistry course, labs and experiments are certainly emphasized. And in those experiments, you want to make them useful. The results, you want them to be useful. So in order to do so, you need to be able to design the experiment in order to have the results be accurate, conclusive, not erroneous. And we're going to talk about in this inquiry activity how you can do that and how you can choose different variables and controls in order to have an experiment that is well designed. Hopefully you have already attempted this inquiry activity on your own and are coming into this video with some knowledge already and are just using the video then as a supplementary resource. Or if you haven't done the activity, I encourage you to do it and then come back to the video, or use the activity and the video in conjunction one with another as you work through the activity. Check in the video or use the video and then try the activities on your own. Okay? So they're meant to go hand in hand. In this activity, our inquiry activity, it starts with talking about a particular experiment. And I wrote here that you could actually do this experiment. It would be a great experiment for you to perform and to actually take the vinegar and the Alka-Seltzer or some other type of tablet that is going to produce the same effect, sodium bicarbonate of some type. Okay, and I just said that this would be a great experiment for you to actually perform and to see the results firsthand. It's an easy one to do. If you didn't do it, that's okay, and we can just talk about it. In these inquiry activities, you are going to study the models, and as we study these models, we are going to make some determinations, some observations, and then draw some conclusions and learn something from each of these inquiry activities. So let's look at question number 1, and it's referring to Model 1. Now before we go into the question, let's just make some observations. They are telling us that this is the situation for experiment before, and then it is mixed, and then after the mixing, this is what the situation is. So we have a before, during, and after situation. And any model, you're going to want to study all of the information that is here. So the Alka-Seltzer tablet here is being dropped into what is 100 milliliters of vinegar. The quantity of vinegar is not important, but just so you know. And notice here that we are given room pressure in all three of the situations. We are given the temperature in all three of the situations. Okay, so again, you can do this experiment and come up with results on your own. It says here, briefly describe the reaction illustrated in Model 1 in one or more complete sentences. Basically what you need to do here is just say that you are adding the Alka-Seltzer to vinegar. You are going to record temperature, as you can see here, and pressure. That would be the room pressure. And you have a set amount of vinegar that does not change. The adding of the Alka-Seltzer actually might change the volume of the solution slightly, but it's really insignificant. Okay? That's all really we need to understand at this point. Okay? Number 2 says, did the room pressure change as the reaction occurred? No. The room temperature here is recorded at 84 kilopascal, and it is recorded here during and after, and it does not change. Okay? So you're running the experiment in the same room, same environment. Pressure is not changing. No change. What 2 pieces of evidence observed during the mix phase of the reaction suggest that a chemical change is taking place? So there are a couple of things that you look for that are indications of a chemical change. Not guarantees, just indications that a chemical change is occurring. In this case, what we have is we have bubbles that are formed. So you notice right here these bubbles that are formed. So a gas is one of the products. And the other one is that we have a change in temperature. Notice when you put in the tablet into the vinegar, the temperature that is being recorded here is changing, and you'll notice as you look at the before and after, it actually goes down. Okay? Did the solution temperature increase or decrease during the reaction? And you should easily note here that the temperature decreased during the reaction. Okay? We already answered that one there. We've got gas formed and temp change. Okay? Alright, moving on to Model 2. Now what we have is, you look at that in Model 1, the setup of the experiment. Now we actually have some data. And notice that they ran this trial 5 different times. That is a great idea to run an experiment over and over and over again, because you're going to make some errors, or you're going to have some high numbers, some low numbers, and you're probably going to want to get more of an average in order to get better results. So it's good to run several trials of an experiment. Notice here what they did is they changed the number of Alka-Seltzer tablets. They added 1, then they added 2, then they added 3, then they added 4, then they added 5. Alright? This is one of your variables. This is going to be a variable. The volume of the vinegar is not changing. It's always 100. Room pressure, not changing. And initial temperature, not changing. All of those are constants or control variables. They're not going to change over the term of the experiment. The final temperature, that is your measured variable, and that is changing, you'll notice, with each of the different trials. So let's answer these questions depending on that are dependent on Model 2 here. Okay, which trial in the Model 2 data table corresponds to the reaction illustrated in Model 1? So the trial in Model 2 here that corresponds to what happened in Model 1. If you go back up to Model 1, you'll notice that you added one tablet, just one single tablet. So that would be trial number 1 here. You're adding one single tablet in this data table. Okay? Consider the 5 trials that produced the data in Model 2. What variable was purposely changed in the experiment? And that would be this one, the number of tablets. Number of tablets. You are first adding 1, then 2, then 3, then 4, then 5. Okay? Purposely. You have control over that. You chose to change that particular variable. What variable changed as a result of changing the variable listed in part A back here? In other words, which of these other variables, which of the other values that we're collecting here, the data that we're collecting, which of them changed as well, and changed as a result of us adding more and more tablets? And that, of course, would be the final temperature over here. Okay? What variable or variables shown in the model remain constant? So that would be your volume of vinegar. That would be your room pressure. And that would also be the initial temperature. Okay? Alright, Model 3. We're looking at another experiment here. We have 5 different alcohols: methanol, ethanol, propanol, butanol, and pentanol. And you don't need to know their formulas right now or even their names. You just need to realize that these are different alcohols. You should notice that the formulas of them, this formula right down here, is very long compared to the first one. So just a little observation. You have more and more elements that are combining here in order to form the pentanol in comparison to the methanol. So, if you notice here, number of carbons, 1, 2, 3, 4, 5. So carbon, the element symbol for carbon is C. This only has 1, this has 2, this one has 3, this one has 4, and this one has 5. Volume of alcohol, you're taking the same amount of each of the alcohols. The boiling point, what that means is you're going to heat up these alcohols they're in a liquid phase. You're going to heat up these alcohols until they begin to boil. And you're going to measure that temperature at which they are boiling. So you'll notice these are changing. The room pressure is not going to change. You do it in the same room all the time. That's not changing. Okay? So, number 8, let's answer this one. Describe the similarities and differences in the 5 alcohols. Well, we already kind of mentioned these, that the 5 alcohols, they have different number of carbons. Okay? The other similarity they have is all of them have the OH at the end, and all of them are also being combined or bonded with hydrogen in there. Okay? So those are some of the similarities and some of the differences in those different alcohols. Different number of carbons and hydrogens all have OH. Okay? Number 9, consider the experiment to produce the data in Model 3. Again, Model 3 here. What variable is purposely changed in the experiment? We're choosing different alcohols that have increasing number of carbons. Yes, they also have increasing number of hydrogens, but we're going to focus on an increasing number of carbons here. Purposely changed. The variable that changed the result of us choosing a compound that has increasing number of carbons is the boiling point. The boiling point changed as well, and you'll notice that it increased here, went from 64.7 up to 137.9 as you went from 1 carbon to 5 in your molecule. All right? Number of carbons and the boiling point. What variable in the Model 3 data table remained constant? Those we mentioned already would be the volume and room temperature. Okay? Volume and room temperature. Okay. Anytime the inquiry activity says read this, that's what you do. You got to read it. It's going to give you a little bit of information in order to help you as you move forward. So when designing an experiment, you need to consider 3 types of variables. The independent variable is changed by the experimenter. That's your choice. The variable is this variable is sometimes called the manipulated variable. We're going to refer to it as the independent variable. The dependent variable is what changes as a result of the change that you made, meaning the change in the independent variable. This variable is sometimes called the responding variable. We're going to be calling it the dependent variable. In some cases, more than one dependent variable is considered. The third, that can get confusing, by the way, okay? So we're just probably going to focus on one dependent variable. The third category involves controlled variables. Those are the ones that remain constant, okay? Those variables that you think might change the outcome of the experiment, but since you're not studying them, you keep them constant. You force them to stay the same all the time. If you have too many things changing, you don't know what is affecting what or what the relationship is. Number 11. This is the key point here. Oops. This is the key point. Number 11 says identify the independent, dependent, and controlled variables for the experiments that produce the data shown in Model 2 and 3. Well, you probably already drew your own conclusion here, but if the Alka-Seltzer and the vinegar, the independent variable was the number of tablets. You chose 1, 2, 3, 4, 5. For the alcohol one, it was the number of carbons in the compound. Yes, the number of hydrogens also changed, but we were just focusing on the number of carbons. The dependent one, the number of tablets, would have been the temperature, okay, or the temperature change, the final temperature. And for the alcohols, it was what was the boiling point. Controlled, I think the controlled in both of these would have been like the volume, the pressure, volume, pressure. Okay, those are some of the ones that we didn't change. A well-written research question states the independent and dependent variables. You want to let your reader know what is being changed, what is being affected, what is being controlled. Okay. For example, a student investigated the effect of the magnesium chloride on vegetation on the sides of highways. Her research question was, what is the effect of magnesium chloride solution concentration on the growth of ryegrass? Okay, so we're going to look at magnesium chloride and what is the effect of magnesium chloride on the growth of ryegrass. Okay, this is where you would then begin to think about your independent, your dependent, and your controlled variables so that you can create an experiment that is going to have conclusive results. Okay? Number 12, again, a key question for us. It says, write a research question using the format suggested in the Read This box for the experiments in Models 2 and 3. So, for the Alka-Seltzer and vinegar, we want to come up with a question tying these two together that would show us what the relationship is. So it could be as simple as just saying, you know, does the number of Alka-Seltzer tablets placed in vinegar change the final temperature? Here, for the alcohol experiment, you would be looking at, does the number of carbons in the molecule affect the boiling point? Does it change the boiling point? Okay? These are questions. The experiments really are going to answer questions, right? We want to come up with questions here and see if we can answer them using the experiment. Okay? A student wonders, will changing the volume of alcohol in a boiling point experiment change the boiling point of liquid? Identify the variables that should be considered in this experiment. So now they're going to change it just a little bit. All right, so what if we have the volume of the alcohol? What if that is the thing that's changing? Is that going to affect the boiling point of the liquid? So your independent variable would be the volume, in this case, of your alcohol. The dependent is going to be, again, still the boiling point. And the controlled would be the other ones. It would be the number of carbons. You're not going to change the alcohols. You're not going to vary those at all. Okay? And room pressure, again, you're not going to change that. What you do want to change is the volume here. All right. Let's consider this last question. And usually at the end of an inquiry activity, there's going to be what is called an extension question. And those are just designed to help you think a little bit beyond what is being discussed here, to kind of take it to the next level. Many experiments designed to investigate the reaction of Mentos with Diet Coke have been documented on YouTube. You can find them all over the place. Design and write an experiment that uses the knowledge gained in this activity to investigate this reaction. Include a research question, the independent, dependent, and controlled variables, and a simple procedure. Okay? Now, of course, your answers are going to vary, and I'm just going to give you a little bit of an outline here and talk you through it. But basically, your question is going to be, is the number of Mentos, this could be 1, for example, does added, the number of Mentos that you add to the Diet Coke, is that going to change the height of the spray, for example? Okay? That could be 1. In this case, your independent variable is going to be number of Mentos. Your dependent variable is going to be the height. You would have to then design a way to measure that height of the spray. Okay? And your control are going to be the volume of the Diet Coke, the temperature of that Diet Coke, and the Mentos for that matter. Maybe the type of bottle or the size of the bottle. You have to use the same bottle every single time with the same size of the opening. Okay, all of those would want to be kept the same. You also could maybe look at what about not the number of Mentos, but what if you were to do Mentos in tablet form versus powdered. Powdered. Okay? So if you crushed it into pieces, you could say, what if I just left it as the tablet, or what if I took powdered Mentos and crushed it in small pieces? Is that going to make a difference? So in this case, your IV would be, your independent variable would be the size of the particles, the size of the pieces of the Mentos. Not the number of Mentos, just the size of the pieces that you're putting in. Your dependent variable would still be the height, and the control would all be the same as well. Okay? So that's what we're getting at, just trying to design an experiment that would answer the question that you were asking. Alright, last question here. Scientists may design an experiment with a control group, which is a set of organisms or samples that do not receive the treatment, meaning the independent variable is not changing. Okay? Scientists can then compare normal changes in organisms or samples with those that might have occurred because of the treatment. The idea of a control group is not the same as a controlled variable. Control group means that basically you're going to let that group run through the same experiment but not change anything to see if the changes occur just naturally, or did they really occur because of the changes that you made. Okay? So, what are some of the variables the scientists could control in an experiment? Well, again, some of the variables that you could control, if you're looking at, in this case it says, suppose the scientist is doing an experiment to determine the effect of a cancer drug on mice with lymphoma. Alright, well, what are you going to control? You want to control maybe the mass of food that is given each mouse. You want to control maybe the volume of water that they are given. You want to control the environment that they live in. Are they in a cage? Are they have a big environment, a big cage to roam around in? Okay. The temperature that they live in, the lighting that they have. All of these you want to make sure are controlled. You also want to make sure that the type of mouse is the same for all of your experiments, and probably the gender as well. Okay? So these are some of the variables that they would want to control. They don't want those to change because they want to see if it's the drug that is actually making the change in the mice, or if it is any of these other things. They don't want these things to be influencing the health of the mouse. And describe the control group. So the control group here would be basically you would have mice, and all of these conditions would be exactly the same for the testing group, for the control group, but they would not receive the drug. You'd have the mice that have all of these things would be the same. Okay? They would still have to have the lymphoma. They would still have to have the lymphoma, of course, but they'd get no drug. And then you would see, do they maybe have any better effect or worse effect or the same effect as the group here that is going to actually get the drug itself. Okay? Alright, well that concludes this first inquiry activity on experimental design. I hope you saw the power of this type of learning approach using inquiry activity, and I'll see you in the next video, number 2, as we will talk about organizing data. Okay, so we'll follow up on this a little bit and look at how we take the information from an experiment and put it into a nice organized manner, table, chart, graph, and then be able to analyze it. All right, I'll see you then.